Okay, ladies and gentlemen, we're going to start off looking at equivalent quadratic expressions. So for our warm-up, we're asked to look at the diagram of products. So this is like an area model. So our first question is to explain why the diagram shows that 6 times, in parentheses, 3 plus 4 equals 6 times 3 plus 6 times 4. So if I'm looking at different ways of expressing the area on the inside of this shape, one way is to take our width, 6, and multiply it by our length. And our length here, I can take my 3 and I can take my 4 and write that separately. Now I could calculate each of these areas directly. So the area of this rectangle is 6 times 3. So the area of this one would be 6 times 4. So I could add these two rectangles together and say this also says 6 times 3 plus 6 times 4 represents that area. So these two things are equivalent. So we could say that 6 times, in parentheses, 3 plus 4 is the same as 6 times 3 plus 6 times 4. So we need to draw a diagram that shows 5 times x plus 2 is the same as 5x plus 10. So I'm going to write this width, or actually I'll write that as my length. Here's 5. And then we need 2 boxes or 2 spaces for x and 2. So this is x, and then this is 2. So this drawing on the outside represents 5 times x plus 2. Multiplying on the inside, that gives us 5x. And then here, 5 times 2 is 10. So our diagram shows that 5 times x plus 2 is the same as 5x plus 10. Okay, so for our second task, we're asked to draw diagrams to represent more products. So we're going to look more specifically at when we have variables. So applying the distributive property to multiply out factors or expand, like 4 times x plus 2, gives us 4x plus 8. So we know that the two expressions are equivalent. We can use a rectangle with side lengths 4 and x plus 2 to illustrate this multiplication. So 4 times x gives us 4x, and 4 times 2 gives us 8. So what we did here, this was 4 and then times x plus 2. So we illustrated that with our model. I also want to illustrate this with the distributive property directly. So 4 times x gives us 4x. We have a plus sign in the middle. And then 4 times 2 gives us 8. So now we have to draw a diagram to show that n times 2n plus 5 equals 2n squared plus 5n. So we'll first use an area model. So in drawing that, we have n that I'm going to represent here. And then here we have 2n and 5. So in multiplying 2n times n, we have 2n squared. And then 5 times n would be 5n. So I would add now these two rectangles together. And then this would equal 2n squared plus 5n. We're also going to compute that directly using the distributive property. So n times 2n plus 5. So if I multiply here, n times 2n, that would give us 2, and then n times n gives us n squared. We have the plus sign in the middle, and then n times a 5 would give us plus 5n. So now we're going to use more of the distributive property directly. So looking at this, I'm going to multiply 6 times 1/3 n plus 6 times 2. Now 6 times 1/3, I would multiply that 6 over 3 n, and then plus 6 times 2 is 12. 6 over 3, 6 divided by 3 is 2. So I can simplify that further as 2n plus 12. In looking at our second problem, we're going to take p and multiply that by 4p. So we would have 4, and then p times p makes p to the second power. And then plus 9 times p would make 9p. Here, I'm going to distribute again. So 5r times r makes 5r squared, plus multiplying the numbers, 5 times 3 over 5, and then putting an r. We need to simplify here, so I'm going to put a denominator. I notice that I have a 5 over 5, so 5 divided by 5 will make 1, so we can cancel those out. And I'm going to be left with 3 over 1, which is just going to give us 3r. So I'm going to write my first term first, 5r squared, and then I'm going to add 3r. We could also have the distributive property where I don't multiply from the front of the expression, we multiply from the back. So if I have 0.5 times w, and I multiply it by the w here, that would equal 0.5 w times w gives me w squared. And then I have, and I'm adding on 7, but I'm multiplying by w, so 7w. Okay, and looking at our third task, we have to use diagrams to find equivalent quadratic expressions. So multiplying x plus 1 times x plus 3, we can use a rectangle model to figure out each part. So if I find this rectangle, multiplying x times x is going to give me x squared. In this one, 1 times x is going to give me 1x, or just x. Here, 3 times x is going to give me 3x. And then 1 times 3 is going to give me 3. In adding together my terms, we could say that x plus 1 times x plus 3 is equal to x squared plus 3x plus 1x plus 3, which is also equal to, if I combine my like terms, we have x squared plus 4x plus 3. So we showed that with a rectangle model. Now, we could also show that with the distributive property. So I'm going to show you that also. So x plus 1 times x plus 3. What you would do is you take x and you multiply it by both things. So x times x and x plus 3. So I'm going to show that with a little bit more work than I would show. So I can also write this as x times x plus 3. And then I add on multiplying 1 times x and 1 times 3, which can also be shown as positive 1 times x plus 3. Then what I can do is multiply or distribute those things directly. So x times x makes x squared. X times 3, I add 3x. Then adding here, 1 times x, I add 1x. And then 1 times 3, I add 3. Combining my like terms again, we have x squared plus 3x, plus 4x, adding the 3 and the 1, and then plus 3. Typically, I don't write this step. I just multiply directly and go x times x gives us x squared. x times 3 gives us 3x, 1 times x gives us 1x, and 1 times 3 gives us 3. So I skipped this step. For step 2, we have to find x plus 5 squared. First of all, it's very tempting to just say x squared plus 5 squared. However, x plus 5 squared means I take x plus 5 and multiply it by x plus 5. So now I'm going to complete this directly before I draw an area model. So x times x gives me x squared. X times 5, I add 5x. I add now. 5 times x is going to be another 5x. And then I add 5 times 5, which is 25. Simplifying, I would get x squared plus 10x plus 25. Now, to simplify that a little bit further, they asked us to do diagrams. So we have x and 5, and another x and 5. Multiplying for each of them, we have x squared, 5x, another 5x, and 25. Pulling that out would give me this, which would simplify that as well. So here, I'm going to switch the order a little bit. I'll draw the rectangle diagram first. So we have 2x and then x and 4. So 2x times x gives us 2x squared. 2x times 4 gives us 8x. And we can see that 2x times x plus 4 should give us 2x squared plus 8x. I'm going to now show that with the distributive property. 2x times x gives us 2x squared. 2x times 4 would give us plus 8x. Switching it up again, I'm going to go 2x times x, which is 2x squared. 2x times 3 would be plus 6x. 1 times x would be plus 1x. 1 times 3, I would add 3. Simplifying that gives us 2x squared plus 7x plus 3. To confirm that with an area model, I'm going to draw my rectangle. I have 2x and 1 and x and 3. 2x times x gives us 2x squared. 2x times 3 is 6x. 1 times x is 1x. 1 times 3 is 3. We can see 2x squared plus 6x plus 1x plus 3. So we would simplify there. Our last one, x plus m times x plus n. So I'm going to try directly first. X times x is going to give us x squared. And then x times n. So I'm going to add on xn. And then here, I'm going to add on mx. And then here, I'm going to add on mn. Verifying that with a diagram, we have x and m and x and n. X times x gives us x squared, x times n. I'm going to write that as nx here instead of xn. So n times x. Here I have m times x. And then here we have n times m. So in looking, collecting our terms, we would have that same thing. So you can see all through, I've been doing this part for writing an equivalent expression without drawing a diagram to just demonstrate the distributive property. So x times x gives us x squared. X times 6 would be plus 6x plus 2 times x. And then plus 2 times 6, which would be 12. Simplifying or combining my like terms, we have x squared plus 8x plus 12. And then for our last piece, x times 2x would be 2x squared. X times 10 would be plus 10x. 5 times 2x would be plus another 10x. 5 times 10 would be plus 50. So again, this would give us 2x squared plus 10x plus 50.